Ashish, shall we start because I have hard stop at 12:30. Okay.
Okay, sir. So let's
Uh,
start the session. So, good morning, everyone present in today's session. On behalf of Smart India Hackathon team, I welcome Shri Rajani, Senior Scientist, TCS Research, Bangalore, and all the candidates to the today's online training session. I am Ashish Sharma, your host for today's session. This session has been specially organized to help you understand the today's topic, that is blockchain and decentralized systems, which will support you in preparing better for SIH 2025. We are honored to have with our expert trainer Sri Rajanji, an industry professional with extensive experience in this domain. Thank you, sir, for joining and providing training to our candidates. Now, without further delay, I would like to invite our respected trainer Sri Rajanji to begin the session. Rajan sir, over to you now.
Thanks, Ashish, for the nice introduction and good morning, all. I think hope you are able to hear me. I'll just share my screen. Okay. Uh, Hope you are able to see my screen. Ashish, are you able to see my screen?
Yes, sir. Yes, sir.
Okay. Okay.
It is
Thanks.
visible.
Yeah. Okay. So I just briefly introduce myself and our group. So just 5 minutes I take. So we are part of TCS Research. We work in several areas of research. You name the area of research we work. So I belongs to one of that such research area, cybersecurity and privacy research. So I had this group within TCS R&I. Uh, so these are the broad areas of research we do in the cybersecurity. You can see we are trying to cover we have almost all the areas of research in the cybersecurity work. I think some of them, of course, we need to work upon. So as of now, so our goal is to develop tools, algorithms, uh, which which influence both theory and practical. So we mostly work in the area of applied research of cybersecurity. Uh, these are the prominent areas. I think you know AI is omnipresent now, and as well the cybersecurity challenge is also there. So one of the challenge in AI adoption is the lack of trust. Correct. So we are doing a lot of work in the area of assuring AI assurance. As part of AI assurance, we are try to build trust in AI systems. uh, Come up with various methods and technologies to check the uh, trust issues in the any AI system. Okay. Now, of course, because now AI is lots of disruptions happening in AI, I think we also quickly need to move to do the research in the AI world, starting now with Gen AI as well. Okay. And now, of course, I think you know recently, so government also DPD Act, the Data Privacy Act, correct? So lots of privacy challenges are out there in the enterprise world. So we are also working extensively on determining the privacy leakages in the applications, and then remediation as well. Uh, of course, AI, I said no, AI helps lot of domains. I think cybersecurity is one of the area AI. We need to embrace AI due to um uh, paucity of skilled workers in this cybersecurity world. So we are working on coming up with different tools for which can aid the cybersecurity professionals to carry out their work. Correct. So that's not how you leverage AI for cybersecurity. So this is another area of work we are working on building resilience in quantum. You know, quantum computing brings a lot of advantages, especially it also brings the disadvantage to the cybersecurity. Using Shor's and Grover's algorithm with the help of quantum computers, you can break the RSA crypto systems and ECD as a crypto system, and also reduce the security of the a symmetric crypto system by the half. Okay. So the challenge is, I think you need to identify all such usages in the applications, enterprise applications, and then list out them. We call it as cryptography bill of materials, and then essentially you need to remediate. You need to replace those crypto primitives with the quantum secure primitives, which is called post quantum cryptography. Already NIST standardized. 4+1, I think five, three signatures already is there, and one KM and another KM is in progress of standardizing it. Okay, so now I think we need to replace the RSA and ECDSA with the post quantum cryptography, but it's a big task. It's called YTQ problem, and in next 5 years, I think lots of work needs to be done to migrate entire enterprise applications, not single application, entire enterprise applications which uses these crypto primitives. Okay. Uh, and of course, we work on most of the enterprise applications are moving to cloud, and there are lots of challenges related to confidentiality and integrity. How do you enable confidentiality and integrity in the cloud? So that is another area of work we are doing, and of course, this is close to. We're also working on blockchain and also next generation identity systems. Correct. I think now similar to other, you have many identity systems, digital identity systems, and each identity has their own credentials. For example, right from the degree, certificates, health records, correct. And there are how do we design a verifiable credential system at large, which is also secure and preserve the privacy. So another area of interesting work we are working on is and the human aspects of cybersecurity. I think humans are the weakest link in the cybersecurity world. Lots of threats are happening in the cybersecurity world due to human errors. For example, most of the major attacks in the cyber in the cloud is due to misconfiguration in the identity access management systems. The adversary is able to sneak through the gain the access of correct due to the configuration mismatch and exploit it and then carry out attacks. Correct. And so how do we strengthen this? Correct. I think we are doing a lot of interesting work in this area. Um, the another area of work is, I think digital currency called CBDC, central bank digital currency. We are working on future of digital economy. So because there are lots of trust and security challenges are there, privacy challenges are there in the CBD systems. We are working near of offline CBD system. So this is an overall area, I think, of research where working. If you are passionate to work in these areas of the research and I think have a good skills, I think you can always write to us for employment perspective. Okay. Thanks. I'll just move on to the actual topic. Sorry, this is a bit of evangelization from our lab side and on the area of cybersecurity. So what I'll do, I'll quickly move on to the today's topic, the blockchain. Correct. I assume. I think so. I assume that you're all already aware of the blockchain. So if not, I think I'll just briefly explain what is blockchain. Correct. So and then what are the different challenges, because we look at the challenges in the blockchain adoptions. Okay. Uh, so what is blockchain? You can see, for example, a blockchain. You can, if an informally, you can look at it. It's a, you can assume that it's a database kind of a thing. Functionally, it resembles a database, DBMS kind of thing. But of course, there are it's bigger than DBMS. But for a simple way, you can see the database, correct? So the database. One thing is, you can't in database you can always do you can update the records, correct? You can delete the records, you can insert a record. But in if you think blockchain, this is called a data. I think I'm going to explain each component of the blockchain in its own blockchain. So you can see that in the blockchain you call the records, or these are they're all linked in a chain fashion, correct? And they're appended, so you can't change any data or record within the blockchain. And of course, who will do this in DBMS? Generally, there's a DBA, correct, database administrator, who manages this DBMS. It's a centralized entity, and there are access privileges given for the other people users who you can update certain fields or certain records, correct, or thing. Decentralized, correct, and this database, or what you call this uh, the data structure you call ledger, is shared across the different entities, which is controlled by multiple nodes. Okay, not the single entity. That means you are moving from centralized to decentralized kind of thing. But so because since moment you move from a centralized to decentralized, what is challenge? Because the challenge is the trust, correct? Um, so how do you establish trust? Okay, so algorithmically, correct? So so this kind of a uh, um, trust can be through, correct, through consensus and smart contracts. Okay, um, which also ensures the integrity of the system. Though the entities, multiple nodes, they don't trust each other through algorithmic way, correct? You can enable the trust through consensus. Okay. And already I told you about, you can only insert, you can also append into the blockchain. And so because I said, because it's an integrity of the blockchain is to be mentioned. You see the advantage of this. You see, you can't make any changes. That means if anybody tries to tamper the ledger or this data structure, correct? You can always it will be always detected. Okay, can detect. Okay. So basically, what essentially what we do is you take the something called hash. I think I'll also say what is hash function. I'll explain you later. Essentially, you take the hash of the information, called record or block, what you call, correct, and then fingerprint it, correct, which is another fingerprint. You can also become the fingerprint of that, correct, and you can, if you want to create a next block, so you have to use the hash of the previous block and then hash of the current block and then connect it, correct, and append it. So in that way, if somebody tries to tamper it, you can always verify it, you can always detect it. So other advantages, it is highly available. So you can see centralized system. One of the challenges, I think, if something goes down, I think its availability is a problem. Correct. Whereas the blockchain systems are highly available, because since the information is replicated across the different nodes, high availability is ensured. Okay. So I quickly move on to uh, the so what you can say, what is the big deal, correct? What is, okay, you can see that you said told database, but so what are the things, correct? So what are the big deal when you compare DBMS to the blockchain kind of thing, correct? So in the blockchain, uh, there is a control, correct, because you're moving from centralized to decentralized. There's always a control, because participants have more control over the data entering the blockchain when compared to centralized systems, correct. So that means you can always it gives a kind of confidence to the participants. Participant can enter, can easily apt to be part of the system. Okay, so there's a definite control, because unlike the centralized systems, correct. And I said there is a lack of trust, but how do you bring trust? So that is very important. That's a beautiful thing about the blockchain. It brings a trust through uh, consensus mechanisms. Okay, I'll explain what is consensus mechanism later. And since there's a transparency, so there is a biggest advantage of blockchain, because it is available to all the participants instantaneously. So it also helps to make the informed decisions making, correct, because it's available. You can see the data records which is moving. Somebody has done the transaction, which is available to all the other participants, correct. Uh, which also helps in avoiding certain kinds of frauds and speeds up the business processing. And I said you can always audit the systems. You can always verify integrity of the system itself. So these are, I think, very important. aspects, correct, when you compare the centralized systems, correct, the blockchain that enables. Okay. So there are many use cases of the blockchain. So I think you can see that a lot of frauds can be prevented. For example, one of the use case you can see that the um, organ donation. Correct. I think there'll be recipient list will be managed based on um, correct, based on the data of the request, and also the based on the urgency, correct, based on critical of the patient, correct. So as I think without this kind of a system, what you can go and have a backdate, you can have a backdated entries, and then your a particular person's name can be become high priority. uh, you can always prevent this kind of a backdated entries in the using blockchain, correct? Because if tries to any do any tamper, you do try to manipulate that, you will be caught because it's a tamper evidence. Some you can always find it out using blockchain, correct? Similarly, you can also prevent the double funding thing, and also you can see most of the problem. You can see that KYC kind of thing, correct? Know your customer, lot of duplicate identities, election cards. I think some people have multiple cards, correct? All those such kind of a thing you can always detect and prevent using the blockchain. So, and also one of the thing is it will be very good. A lot of applications are more, I think in the supply chain world. Um, uh, that's a very good use case for a blockchain in supply chain system, correct? You want to one of these problem in supply chain is traceability issues, correct? I think right from the source of the manufacturing to the customer, correct, who is using that, correct. So that entire chain has to be validated, correct, and there should be integrity in that. So it should not happen that I think in between you can replace that an item which is produced and with the other duplicate items, correct. And then so how do you prevent it, correct? So of course this requires other sensing technologies along with the IoT kind of thing. You can always check the provenance of the goods, so that's a good application of a blockchain, especially for high valued items or critical items such as the medicines, correct. You can always enable it, okay. So because how do we solve it? Because in blockchain you store any as soon as a transaction happens, correct. I think you can do any inventory, lots of transactions going to happen in supply chain. It will be uh, recorded, and this is visible, correct, to all the other stakeholders of the system, supply chain system. That way you can prevent it, okay. uh, and also I think you can see that especially discrepancies you can always avoid in siloed copies of data, correct. uh, because you can always reconcile these transactions between the interbank, example interbank payments, for example reconcile of CDRs, correct, call data record, detailed records, correct, between the telecom operators, correct, something like that. So you can always do, which is also instant reconciliation using blockchain, because you can always look at the other nodes, correct, because the records are available at all the other places as well, correct. Entire blockchain is available, so you can always validate it, correct, your status, and again you can also update your blockchain status, correct. uh, so I think so so this enables when you move away from centralized to decentralized, correct. And also avoid single point of failure, already told. This is a you can also uh, eliminate the intermediaries, because a lot of intermediaries are there because of a centralized version. You can always uh, do away with them. So this using blockchain, because it always empowers every participant equally, correct, and enables consortium control. So lots of it can also reduce inefficiencies in the process, correct, in the which is system, especially in the shipping industry. I said most of the things in supply chain, correct, delay in treatment. Um because the data is available at all the places, because it is easy to make decisions, correct, because the data is up to date, and and you can always do the transactions, or you can, based on the data, you can always take decisions, and you can always prepared for this kind of a, so you can always eliminate the inefficiency in the processes. Okay. So these are some of the use cases, correct? Not limited. I already explained you the when you compare distributed ledgers and blockchain kind of thing versus centralized, correct? So it's always, it is, you can always do a public scrutiny, correct? So anyone can, who is part of the blockchain, can validate it, correct? Correct. There's a transparency is there, and there's a privacy is there, correct? Especially there are permission kind of a thing. There's a privacy, you can say permissionless. There's a privacy. Some places, I think, that also can cause a problem. I'll explain what are the challenges, correct? Because since blockchain enables the privacy, anonymity of the transaction between the users, then there are lots of challenges, correct? So how do we solve that problem? And then integrity is there, redundancy, because of redundancy, available, high availability, correct? And there's a trust anchor. Okay. So I'll quickly move on to one of the thing, very important question, I think we need to, when blockchain was a hype, correct? So everybody wants to use, adopt blockchain. Okay. So this is a good lessons. I think one way to know whether we need to have a blockchain or not, because blockchain also comes with a price, correct? It comes with a computational overheads, and sometimes latency is there, because um, you need to run the consensus mechanism. Through that, I think the transactions are finalized, correct? So there is a certain overheads. You always need to know whether we need a blockchain. So though this is a old paper, I think now you can always think you can go back and you can also update yourself, correct? So for example, let us go through this flow chart, correct? So do you need uh, a state? That means you need to store any state. For example, um, if you don't need to store any state, if it's a stateless kind of thing, then directly you can say you don't require any blockchain. Okay. Suppose you need to maintain the state. For example, one of the state is account balance. Okay, I need to maintain. Correct? Banks has to maintain the account balance of each customer, every customer. Yeah, correct. So in that case, it comes here. Correct? Are there any multiple writers who will update? Okay. So assume that if you're doing only banking, and only one bank, like a State Bank of India or HDFC Bank, so it's only one bank is maintaining or managing these state updates, and you don't require blockchain. Correct. Now, yeah, in that case, if there are multiple people are writing, or maybe multiple entities are updating this state, okay, yeah. And then we need to see, okay, I think assume that there's an interbank kind of a transfer. Let us assume that if there's a trusted third party, correct, who manages, correct. If you deal, I think this always on managed to TTP, trusted third party. In that case, also don't require blockchain, correct, because everybody is trusted. They can simply run this. You can do these state updates. No, suppose you don't trust each other, then you can say the simplest. If you do, you know all, who are all updating all these states. If you don't know, then it becomes a permissionless blockchain. Correct. I think most of you are aware of Bitcoin as a blockchain. Most of you, say, if you ask, I think they don't know about blockchain actually. Say if it's a hyperledger, many of the people they don't know. But if the moment you say Bitcoin, I think everybody is aware of. Correct. So so that is a permissionless blockchain. Suppose if you know, correct, we're all updating. That means we're all part of this consortium. Correct. Again, if you all of them you trust them, I think you don't require blockchain. And if you don't trust, then again, is it publicly verifiable? That means, is it allowed to public people to verify it? Correct. So in that case, it's a public permission blockchain. So if you don't allow any public, I think assume that's consortium of banks. Let us assume they want to do interbank transfer, and then they don't allow public. In that case, you can say it's a private permission block. You can see these are different flavors of blockchain. There are three flavors of blockchain. Sometimes, of course, uh, there are different ways to categorize blockchain itself based on the different you can say different types entities. For example, consensus, based on the consensus mechanism itself. you can also categorize the blocks. I'm going to discuss those things. So you can see that this is a traditional supply chain management. You can see that everything is correct. I think it goes one typical supply chain, correct? One entity to another entity, and nobody knows what is happening at any instant of time. Only the um, adjacent entities will be aware of, correct? Part of the supply chain. If you see the power of blockchain, you can see that. So now you think everybody is connected. I said no, you can always reduce inefficiencies and you can do proactively more and faster way, correct? So that's the power of the blockchain. Can see. Okay. So are you able to hear me? Sorry, I just heard something. Yeah. Shall I continue? Hello. Are you able to hear me? Because I can't see. Can you unmute and talk to me? Hello.
Here.
Oh, okay. So thanks. Uh, and we'll now look at the formal definition of blockchain. Okay. I think so far we have just informally discussing all this, correct? So I think we see that blockchain has a mm, okay, it's a distributed ledger, correct? So essentially what happens is there are um, uh, granular level. You can have the it's a transaction. It all starts with a basic unit. So you can say basic operation or basic unit of operation in blockchain is a transaction. Okay, so this transaction always happens, correct? Asymptotically between two entities like Alice and Bob kind of a thing in a distributed manner. Uh, so the transactions, suppose if Alice wants to perform a transaction with respect with Bob, you can say Rama wants to perform a transaction with Sita. So it has to be signed, correct? So you need to ensure that a basic cyber security hygiene is maintained. So that means uh, the transaction eventually will be signed by digitally signed using cryptographic schemes, and then such kind of a transactions are grouped into blocks, correct? And these transactions, because in a distributed setting, these transactions can come from different nodes. So and then it has to be grouped into the blocks. So there are so for example, you can see challenges, correct? For example, each node receives the transactions, correct? May have different orders because the way it has received, the order in which it is, it may be grouping them in a ordering can be different, because once you order the transaction different way, the state of the states also can be different, correct, for each of the node. So there are challenges, correct? How do you order this transaction to a group into a block is also a challenge. And then there are mechanisms. That means again you need to run the consensus. So there is a mechanism to come up with that all the order of the transactions within the block is same across all the nodes. Okay, and that needs to be ensured. And then this block has to be validated, correct? I think how do we validate, because each node has blocks. Now see that everybody has same block. We have the same block, correct? Block states. Okay, list of transactions, the order of the transactions. Once you execute a transaction, the state change also. What is its state change cost? This state change also, the integrator of the state also should be same across the should be across all the nodes, correct? So how do you manage this? So that needs to be validated. So that has to happen through consensus mechanism. So and then once you create a block, as I said, the blocks has to be cryptographically linked into the previous one. So using hash mechanism, correct? I'll explain how it works. And then uh, these new blocks are replicated across all the copies of the ledger. For example, if many nodes are owning this ledger, correct, managing this ledger, it has to be replicated, and that should remain same across all the nodes. So that forms essentially a distributed. This is how you can say look at the formally the definition, because you can see that when you can these are all different entities of a blockchain. You can say protocol stack. You can say the stack of the blockchain typically, correct, apart from the communication mechanism. So it's not included here. So there's a distributed ledger, transactions needs to be digitally signed. So there's a crypto primitives, uh, need to be blocks, and then consensus required, correct? So this how you can define a blockchain. This is a, you can say, typical stack of the blockchain. I think based on the different types of blockchain, I think these wallets also required, correct? So that means you need to store your public keys there. Okay. So essentially, this is an architecture if you stack of the blockchain. Okay. Uh, I'll just briefly go through the different crypto mechanism, because I am assuming that I think most of you may be aware, but still, for the sake of completeness, what essentially does, everything is through done hash, correct? Validation of transaction, validation of block, everything is done to a hash function. So you know what is a hash function? Basically, a hash is always takes any input, always produces a random, unique, fixed size output. That means if the input you take any time the input is same, you'll get a fixed output which is again random, correct? Uh, Using a one-way function, correct? So I'm not going to detail of hash functions, properties of hash functions. It's also I think pre-image resistance and all those things need to be in. So it's already there's a SHA-3 is a best now this high secure hash function, you can always use it, correct? uh, and it is collision resistant and it is invisible to mm, I think there's, for example, if I give two inputs, uh, that should produce same output, so that's called essential collision. So such kind of, can I find out such kind of inputs, is again a, it is invisible. Okay. So as a, for example, I told you it is an input text frequency SHA-256, correct? If you do a hash of one, if you let binary value, you can say 001, that. So this is a random fixed size 256 bit output. You can see there's one bit change. If you say binary, if you represent there's a one bit change, I can see that the output also drastically changed. I think very different, correct? So, and you can take any of the word. I think this hello Ramanjan. You can say these are two words. I think you can always hash it into a fixed size. Okay. So this is all the transactions are hashed, and then correct, and then this concatenator to come up with a aggregated hash for a block, and you combine the hash of the previous block. So the hash is essentially very much important. It's an entity of a blockchain crypto system. Okay. And this is how the typical transaction. I'm just give an example of a transaction. This transaction structure can vary depending on your use case. Correct. So this is typically a banking use case. So you can say that in banking, what will happen is there's an input, there's an output, uh, there's an amount, and what is it total? Correct. So I think, for example, from account A, you are sending 1,000 rupees to account B and 500 rupees to account C. Total 1,500 rupees. So this is a typical structure of a transaction, correct? This is sender, this is a recipient, and you need to do some validations, correct? You need to check the balance, correct? Uh, so that's how this is going to work. Okay, and I know how to compute the hash. You have to compute a hash of entire thing. You're going to get a fixed 256 value, correct? And you need to sign this transaction, correct? Because why do you need to sign the transaction? Because this is initiated by Alice or Rama to Sita. So Rama should not come and Rama should not come and say I have not done this transaction, correct? So non-repudiation. so so that prevents non-repudiation kind of thing, correct? And also you can't unauthorized kind of a transaction not possible, because this is typically the transactions are signed using the private key of a that person or that entity. Okay. So this I said now, what do you? So I think in this case you can see that you also require asymmetry in blockchain, correct? So because you need private keys to do the digital transactions, public keys to validate the transaction, correct? Uh, in case of cryptocurrency, these public keys are hashed into such a way that I think it's difficult to identify the entity who is doing the transaction. So they using public keys generate many pseudo identities, and it's in that way user is anonymized in the cryptocurrency, in the Bitcoin world. Okay, so so this is because one of the problem, correct, in the cryptocurrency like Bitcoin, the challenge you remember is uh, you need to sign transact. For example, I have 1,000 bitcoins, correct? Now one bitcoin is, I think, $85,000, correct? That's the challenge, correct? And how do we do the transaction with that bitcoin, correct? And so that means you need to sign, correct? So how do you sign? So you have to sign using your private key. The way you need to store private key securely, correct? I think these private keys are stored in a wallet or secure place. Okay. So essentially, what will happen? Essentially, you can see most of the attacks in the cryptocurrency world, Bitcoin kind of thing was happening. Uh, is because of adversary steals your private key, and then what he does is adversary does is, I think, adversary will transfer all the money, all the currency, the crypto coins which is there and under your name, to himself or herself, correct? And then you can't trace it because in the Bitcoin world, there's an anonymity, okay, and you cannot find the this recipient, okay. That's the challenge, okay. So that means once you lose your private key, that means you lost as good as your um, coins or your bitcoins, okay. So that's the danger with respect to especially in the private public blockchain systems, and then whenever you lose your key, private key, uh, I think you're losing that asset which is associated with that with the private key associated with that asset, okay, and you can't trace it, okay. So, and also the other challenges they do is that lots of attacks also do, they encrypt your wallet itself. Once you are encrypted wallet, you can't use them because all your private keys are associated with that inside a block wallet. And then this kind of ransomware attacks they do. And they adversary will say give transfer some bitcoins, or then only I'll release your wallet. Okay. So that's the danger in the especially in the public blockchain systems, correct? And where the anonymity is there. So one should be very careful, correct? And also brings a lot of other challenges. For example, so why they do a lot of unhealthy transactions, correct? I think you can see the drug mafia trafficking people. So they use a Bitcoin kind of a systems to transfer to do the transactions, because you can't catch these kind of people over the Bitcoin systems, correct? Due to anonymity. So So I think that's why in India also I think it's discouraged, correct? There's no you can't legally do this in India, correct? However, if you have done, I think you have to pay tax. So in that way, trying to legalize it, correct? I think so. So there's huge tax on using this. If you're performing any, you're getting a lot of money through Bitcoin thing, okay, and it's discouraged. But some countries they're allowing. Uh, um, it's a matter of debate, correct? Do we need to allow this kind of a system at all? Okay, so that's why I think government of India also looking at coming up with CBDC kind of a thing, central bank digital currency. It is also similar to a. It's not exactly you can see that a Bitcoin kind of a thing, correct? Because you can say the lots of fluctuations of the currency happens because these don't have any control kind of a thing. Um, if you want to do a real kind of, can want to a digital rupee, so there are CBDC which is more controlled, correct? um, uh, I think it's totally different than the cryptocurrency world, okay. uh, so uh, I think what is ledger? We are talking so many things about ledger. I think you see that ledger is nothing but a set of blocks which is cryptographically chained, and every node maintains this ledger, correct? And it's stored digitally. Okay. I think this ledger generally maintained, correct? In the olden days, also I think banks used to maintain physically these ledgers. You might even not have seen because you're not born at all that time. Do that regime. We used to do a transaction, go to the bank, which is not connected, correct? They show a big register they maintain. They you have to you give a check, and then they will open. There's a big page for you in that book, correct? There's a ledger, so they, and then they reduce the balance, correct? Come up with new balance, sign it, and correct, and maintain those checks for many years. So, and then money used to be given. So that is the physical ledger they used to maintain for many, I think. So past decade, I think everything is now moved to digital. Of course, they also maintain sometimes the hard copy of high value transactions, correct? This is a single point of failure in centralized systems, correct? So I think you need to do a lot of backups, and transactions correct, may not be valid or complete, can be altered as well, because a certain backdating is possible. In case of a distributed ledger, correct, already these issues are resolved using consensus, but it comes up with a different challenge, correct? It comes with the cost. So what is the cost? So transactions throughput issue. That means it slows. Okay. Um, and there's a lot of latency and scalability issues. Correct. If number of entity nodes are increased, because the consensus mechanism, most of the consensus mechanism done, which is lot of messaging overhead is there, because to run that consensus protocol, they need to do a lot of message passing. So because of that, I think there is a delay, network delay, latency, scalability issues, and there are challenges. Correct, the network itself may be partitioned. In that case, I think how do we solve lots of problems with respect to, because moment you move from centralized to distributed, a decentralized environment, lots of challenges, other challenges comes into picture. So that needs to be addressed. That always please remember that if you want to have such kind of a flexibility or features, it always comes with a cost. So the trade-off, there are always trade-off, correct? That needs to be balanced based on the use case or business needs. Okay. So this how these transactions getting into enter. For example, you can see that this is so this is taken from the NIST um, paper, correct? So this is one transaction is fired from the node, correct? I think this has to be um, mm, I think this has to be reached, correct? I think assume that everybody is preparing this block. So you can see that this it's propagating to across all them. Just giving an example of a transaction. In general, this is applicable to block, kind of thing, assume that. So this propagated and is verified, and then it's everybody. I think all the entities will have a using consensus. I think they'll maintain a same state of the blockchain. You can see that everybody is now on par, correct? This is still, I think this is somehow still needs to be updated, correct? Eventually, it will be updated eventually. Okay. Uh, so this is how does happen. I'll go into block. I can say blocks. Transactions are grouped into block, correct? Transactions can be submitted to any node. Transactions submitted in nodes, correct? Ordered. So the challenge, because in a centralized setting, correct? Who will create this block? Correct. I think in centralized setting it is easy because one entity is there and that entity will create the block. But uh, in case of decentralized system, who will make decision? Correct. Who will create this block? Okay. So there are many ways of block creations possible. Okay. So one of the way is a very popular way uh, is um, based on POW, correct? Proof of work. Okay. In the example, you take Bitcoin. So there are special entities called miners, correct? So these miners, they need to solve a puzzle. It's basically a proof of work kind of a thing. Okay. So I'm not going in detail about the proof of work kind of a thing. What exactly? I just give you an hint. Okay. So that means what is exactly POW? There's an assume that now already a blockchain has a current hash of the block is known, that everybody is aware of the current hash of the block. So this hash of the block is known to all the miners or these special nodes. Now you have to take this hash as an input and come up with a seed. Okay, seed is something called nonce we call. Such a way that when you combine this the previous hash of the block and this nonce together, uh, the out of hash of the, that means when you do hash of this, you'll get an output. that output should have a certain characteristics. What is the characteristics? Whenever you do a hash of this thing with the chain hash of the previous block plus that nouns, you need to come up with computing nouns, which should give me the k number of leading zeros. Assume that 5 leading zeros. So computing that kind of a nouns with the with the current hash value, so it's a hard problem. That means you have to do solve this, correct? You need to run a algorithm to compute this. Okay, and whoever does this, solve this puzzle, he will stand up and say, I have solved this puzzle, and this is the proof. Because everybody can verify that proof easily mathematically. Because I moment I give the nouns, everybody, oh yeah, yes, correct, you are the right. So then that node will be allowed to create the block. Hello, sorry. I'm hearing disturbance, some noise. Everything is fine. Okay, thanks. So and then because and then he'll be the winner. I think then he will create the block because he has a lot of transactions. He will uh, all these transactions he will order it, group into a block, and he will get an incentive. What is incentive? Transaction fee you will collect, and also since you create a block, you are the owner of block, you will get a sum. Assume that one of the example is you will get a 10 bitcoins, something like that. So that's how the miners are incentivized. It's a beautiful way of achieving the trust among the untrusted nodes using proof of work. Okay, so unfortunately I think that's how this uh, uh, it leads into other challenges. Okay, and lots of attacks are possible. uh, uh, when the Satoshi, correct, Nakamoto, I think nobody knows who is the Satoshi Nakamoto who created this Bitcoin system, correct. Is very beautiful, mathematically very perfect, correct. Solving, realizing a consensus using POW, but it has lots of inherent challenges. I think uh, we can discuss sometime, okay, later in this. Okay, so I'm not going to deep because already I told you there's a block. I think maybe excuse me for visibility. I think not able to see correctly. I think the block is a set of transactions, correct? And there's a every transaction a date and everything. There's a timestamp and block size is fixed, correct? And you have to take the hash of the previous block, and you need to give the proof of come up with a nouns which is using POW, correct? And then this block is signed by the miner and everything. So this is how a block structure looks like, correct? So see, there are again for some data structures called Merkle tree. It is very much useful. For example, why it is very much useful is because uh, you have lots of transactions in the block. You want to how do we manage this? How do you arrange these transactions, correct? In we math cryptographically so that it is easy to verify. For example, if somebody wants to validate whether my one transaction is part of this block or not, how do you do that? You can essentially come up with this kind of a Merkle hash tree. It's a complete binary tree. You can see that it's a complete binary tree, correct? The nodes, leaf nodes will be the hash of the transactions, correct? And you can see that you will combine two transactions, come up with like this. So I think you can see that this like this. Okay, if you have here you can say four transactions, maximum. This is because level 2 you can have a, you can say this is you can have four transactions, because, correct. So if you imagine, I think it goes further down for 8 transactions, another level, correct, something like that. So so the depth of the tree will indicate number of transactions can be grouped into the tree. The advantage with this is, suppose you want to search, uh, if somebody wants to search, because he needs to know, because only half of the tree, okay, no need to because already hash of the root everybody knows, correct. And then this part, for example, my transaction is part here, I need to validate whether transaction is, I think you need a hash of this transaction available, and just you need to hash of the right tree, immediate to the root. I don't require any hash of these intermediate things. So essentially, it reduces the search by a 50%. You can see, so that's how it's an efficient way of arranging the transactions within the block using Merkle tree. Okay. And I already given example how it is done, correct? This is how it will be arranged. Okay. So we can see that that's how this, for example, given block, chain block, you can see that this is how you have maintain this Merkle tree root hash as well. So that's how it is be maintained within the block. Okay. And you can see that this is how it is connected as a chain form. You can see that cryptographically verifiable. You can see that this is how it will be done. Okay, because the blockchain is evolving over a period of time, correct? And I said no, different types of blockchains are there. I'll try to rush little bit, correct? Um, Apologies for that because of paucity of time. I can see blockchain already. You can do permissionless blockchain, permission, and then a hybrid kind of a thing. Correct. So what is permissionless blockchain? I said it is all based on the um, work. So proof of work has its own challenges. Correct. Um one of them is Bitcoin, as example. There's an Ethereum. Correct. This is a proof of stake. Correct. Instead of running proof of work, can I come up with stakes? For example, so uh, for example, in this case, SBI. If SBI is part of the blockchain consortium, SBI is given a high stake. Maybe small Grameen bank will be given lesser stake. Correct. So the higher the stake, that means higher possibility probability of creating the blocks. So that's what a proof of stake. And there's a proof of elapsed time. So this is proof of knowledge. So there are proof of X. So based on that, these permissionless blockchains are designed. Okay. And there are permission blockchain. There are blockchain based on world state maintains state based thing. They run a consensus mechanisms, correct? So an example is Hyperledger. Um, and also this kind of UTXO kind of model, unspent transaction output, correct? You can, for example, you can always split. For example, I have a 10 rupees. If you make a transaction of 7 rupees, so you'll get a change of 3 rupees back. So that's an example of UTXO kind of thing. So Coda used to have this, correct? And there is within the permission there's order, execute, and execute. That means first order the block transaction a block, then execute each of them. Because of that, there are throughput issues. So Hyperledger came up with an execute kind of an order, execute order. That means you do the execution of individual transactions and then and group them into a block and then commit into a blockchain. Okay. And there are variations of these two possible hybrid mode, okay, which also uses a bit of permissionless and permission. Okay, so this is a categories of blockchain, correct? You can see whether you can use permission blockchain use cases. For example, you can use it as a decentralized platform. If you want to do public facing kind of a thing, correct? Blockchain permissionless already given you how what is the public facing data, correct? You can inspect the data and contribute, and you will have a full transactional history. If you want such kind of a system, you can always go with permission. Anyone you can track the transfer of asset between accounts. So, and somebody tries to manipulate it. So you want to detect this kind of false data items. So data immutability. So transaction throughput capacity. So these are all the use cases, correct? So no centralized entity, correct? This is use case. POW, is already explained you, correct? So I'll briefly explain what are different types of attacks are possible. For example, one of the famous attack you might have heard in case of cryptocurrency is 51% attack. So what is 51% attack is because I said no, the block can be created based on proof of work. So there are miners uh, who try to solve this puzzle, who will able to create the block. So they've proved that. I think you suppose the miners have their own computing capabilities, correct? I think you can see that they require huge electricity to run these kind of mining. Miners, they maintain huge electricity, correct? For one of the example, typical uh, amount of electricity used crypto Bitcoin is you can light entire Ireland country. So that is the energy, correct? It consumes. So that's a lot of investments need to be made, correct? It ends up with that. I think you may have some kind of a entity who have lot of computing power when compared to other miner who doesn't have much computing power. The probability that you may mine the blocks higher, and that means it is a sort of moving from decentralized to centralized kind of thing, correct? Again, you can take control, and you can and also you can discourage other miners to mine. So that means you're trying to establish an autonomy over the entire blockchain. The purpose of blockchain is to make decentralized, correct? So using 51% attack, you can now there are lots of research happening. You don't take a 51%. They already proved that. I think if you have a 21% computing capabilities, when you can do these kind of attacks. Okay. Uh, there are many attacks related to timing problems, clock drift, and distributed denial of service, correct? And eclipse attacks are possible. Uh, and because the network attacks are, because you can partition the network, correct? And because one of the challenges, if you partition the network such a way that you don't know the actual state of the Bitcoin, cryptocurrency, whatever, because the transactions which is performed on the other side of network is not visible totally. So you can carry out a lot of double spending kind of attacks um, as possible using Eclipse and all. Okay, and there are a lot of replay attacks are possible. Double spend is one of the challenge, correct? So that means how do you prevent this kind of double spend attacks? Again, there is a lot of changes done in the way you do consensus algorithm. So block conformability. For example, in earlier case, generally typically it takes 10 minutes of time to mine a block, correct? Uh, because of this 51% I think lots of attacks are possible. So what you do, an adversary will keep a powerful miner keep mining the blocks, and he will be solving the puzzle, correct? And he suddenly will come up with say this is come up with a new block which is a correct uh, length of the block is higher, because generally because of that you can have forking, correct? Blockchain can be forked into because of the network inconsistency and so many things. So the blockchain will be forked, and they made a rule that the longest chain wins. So that means if my transaction is part of the block, which is part of that longest chain, then only it will be honored. Then the other chain, the transaction, the other chain will be will be not considered at all. So the adversary can, because of this 51% attack, they can do lots of such kind of a mischievous thing. Correct? They can also do double spend attacks. Okay, and of course, you see a lot of, because you write a smart contract, there are a lot of vulnerabilities in these smart contracts. Correct? And because of that, you can see Ethereum DAO attack, one of the famous attack few years back. They stolen millions of uh, ethers, and you can't recover them because of small vulnerability in the smart contracts. And of course, the Sybil attack and Byzantine attacks are possible. So we can see that uh, this can be a scary, but I think some of these attacks are prominent in permissionless kind of a blockchain. Of course, I think most of these attacks are not relevant in the permission blockchain. Okay, so I think so. I am just keeping, so in the interest of time, correct? I think so. This is a permission blockchain, correct? So I think because already what is permission blockchain already told you, correct? So certain users only perform queries. So I think uh, only can write. So there are restrictions. If you want to part of consortium, there is rules and regulations, correct? Assume that you can think it's as a banking interbank kind of a transaction. So so you can use this permission blockchain in such kind of scenarios, correct? I think uh, uh, I think so. Some of the use cases I already told him: banking, supply chain, insurance, and healthcare. You can use them, correct? So I can see that I'll skip this one also because it's okay. So these are different use cases: supply chain, already said food safety, logistics, interbank transfer, payments, trading, identity management, because this is coming up, correct? I think I told you. And healthcare is very much useful, provenance of the records, correct? Um, uh, so this is some of the industrial use cases of the blockchain. Okay, maybe I'll just take this slide alone, and I think then I'll stop it. I'll open for many questions. Okay, so there are technical challenges in blockchain. So one of the biggest challenge in blockchain, maybe poor adoption of blockchain, is the performance and scalability issues, because it is very slow due to complex um, insert. But means how do you do the blockchain committing the blockchain to the so transaction to the blockchain, correct? So that means every node has to execute these smart contracts, and they have to exchange the results of the smart contract of each of the nodes through consensus mechanisms. And I said the consensus mechanism is not scalable because it's message lot of messaging over it. I'm just talking about the permission kind of a blockchain. Okay. So more peers means more complexity, and it reduces throughput. So that means it can't scale with number of users. Okay. So there are different flavors of blockchain scheme. I think Corda kind of thing, peer-to-peer kind of a is possible. Again, you can't generalize, correct? Maybe so that is one challenge that you need to look at for my use case, what kind of blockchain is useful. Okay. I said consensus mechanism. I already told. I think CFTs are less crash fault tolerance. Um, only is maybe is faster when compared to Byzantine nodes. So Byzantine nodes is nothing but a node which can is very difficult to predict whether because it behaves most of the time has harnessed node and behaves sometimes maliciously, and it's very difficult to detect maliciousness because you know because of a distributed setting and because of inherent faults can be there, so you can always think maybe this is a due to fault. And there's already impossible proofs as well in a asynchronous kind of a network. uh, it is difficult to detect any Byzantine node. Even a one Byzantine node is so there's an impossibility proof. Okay. There are a lot of impossibility proofs with respect to consensus, that too in asynchronous. Okay. So I'm because I'm not going in detail because I said this entire blockchain is a semester course. I'm just giving you the briefly correct. The slow industry adoption is one of the major is consensus. Hindrance is consensus, correct? In case of a permission blockchain, no permissionless, there's a privacy is enabled. But in case of permission, uh, there are challenges, correct? I think so. There can be link up. How do you do unlinkability between multiple submissions? Um, how do you do selective disclosures of transaction data because you may require for auditing purpose, correct? So these are the privacy challenges also there. And again, with GDPR, for example, if you're doing a cross-country kind of a thing, who wants this blockchain? Who wants this data? Correct. And how do you do these GDPR regulations? How do you, for example, say right to forget? How do you delete something? A lot of privacy challenges with respect to GDPR also in blockchain. Okay. So and also interoperability because you may have, I said no, there are different types of blockchain systems will be there. Uh, and then they need to communicate with each other. So there are a lot of interoperability, correct? So currently, you can see that in traditional thing, there's an escrow kind of a mechanism. One of the way to solve this interoperability is come up in a trusted entity called escrow, which is both the parties agree. Uh, uh, but again, escrow mechanism becomes slow, correct? And how do we do an interoperability without any third party kind of an escrow mechanism? And also because now, see, you want to do query correct for some audit purposes. I think you want to know. I think now since that the blockchain, if it's growing every instance of time, correct, as every blocks are created, how do you do query the blockchain? So that itself is a big challenge. Correct? Can I come up with an efficient query? The queries can be complex. Correct. So how do you solve this problem? Because in database it is easy because it will be you have a lot of indexing and there is an efficient way to do the database query, but it's very difficult. And also need to a lot of key managements. This like I said, it requires a lot of cryptography. If your key is not secure, I think you can difficult to correct ensure security of the transactions. Okay. So as I already said about smart contract security, I think that's a challenge. So that too, especially in a public blockchain system, um, smart contracts, if they are vulnerable, gone. Correct? You can't you can't do remediation. You can't revert back. Um, And also you can't do the reverse of ill effects, correct, uh, in a uh, public blockchain system. But in private blockchain you can do, but again you can't change because you have to come up with a new transaction. Everybody has to agree, and then this smart contract has to be needs to be changed because now it has to be, you need to, correct, you need to restart the system. So there are, so you can say patch mechanisms. So it's difficult in patch mechanisms in a blockchain world of all, because everybody has to be this patching has to be done for every across all the nodes, and they have to be same time it should be available, correct. So so I didn't suppose if you need to do reversing of those transaction states, again you have to write new transactions, correct, execute those transactions will also follow. So, and auditability of course is there, but then there are lots of privacy challenges. How do you address the privacy? Can you come up with a privacy preserving audit mechanism? Is a challenge with respect to blockchain. So this is just telling you the consensus mechanism. Your bitcoins is, I think, comes here, I think, very low throughput. You can see that, correct. And as the nodes increases, throughput comes down. uh, so that's the problem. Okay. This is one of the biggest challenge in the um, blockchain. Okay. So I'm not, okay, there are there are many ways to solve this problem, scalability challenges, um, using trusted entities, correct, pluggable consensus, come up with a, based on use case, look at the use case, come up with an appropriate consensus algorithm, correct. So you can see that one, so that means sometimes you may not have a single blockchain for solving all the use cases. That doesn't work at all. I think you need to choose based on use case, which kind of blockchain is useful. That needs to be really thought through and then deploy. Okay. So okay, so what I'll do, I'll leave at this moment. If you have any questions, I can take, correct, in the interest of time. So okay, I think uh, over to you. Uh, okay, Ashish.
Okay, thank you, sir. If you have any questions regarding the today's session, so you may ask.
Sir,
Some,
can
some,
I get the PPT? I share my mail in message.
I'll see because I need to check some of the contents, or I think I need to redact it and send it. Okay.
Okay, sir.
So I think if you have any queries, you can uh, ask me now. Okay, I am seeing a lot of apart from PPT sharing. Okay, so any other thing you would like to understand or know? Yes, I think I'm seeing no comments or no questions. Okay. Uh,
Okay, so thank you everyone for your active participation, and a special thank to our trainer Sri Rajan ji for sharing valuable knowledge and guidance and made this session wonderful.
Excuse me, sir.
okay.
Excuse me, sir.
Yeah. Yes.
Sir, I have a question regarding consent letter. What is the format for that?
I didn't. Sorry. I know. You're asking to me, or I don't know. I don't know about what is concern letter.
Okay, sir. I'll get it cleared later. Thank you, sir.
So thank you everyone. So we wish all SIS 2025 participants the very best for your journey and innovations. Stay motivated, stay creative, and keep innovating for India. We are closing the session now. Have a great day ahead. Thank you once again, sir, for joining the session. Thank you, sir.
Thanks. Thanks. Thank you all for patient listening. Yeah.
हाँ सर